Start. Okay, so let's start now. What we have done yesterday? Lens maker formula, right? So what we have got? 1 by f is 1 mu 2 minus 1, 1 by r1 minus 1 by r2. This was the lens maker formula we got. So we are going for some certain interpretation today. Are you getting it or not? I think the entire class will be based on the interpretation, correct, with respect to the lens maker formula. So before going to the interpretation, let us try to understand the types of lenses at first. I told you yesterday that whenever we talk about convex or concave, we may be having equiconvex, plano-convex, biconvex, concavo-convex in this way, right? So we are supposed to understand right now this type of lenses, whether it be convex or concave. Are you getting it? Please write types of convex lens. Types of convex lens. Types of convex lens. Got it? And in point number 1, you please write biconvex. Biconvex. So what does biconvex means? I told you yesterday, biconvex means having two convex spherical surface. Are you getting it or not? In case of biconvex, this spherical surface need to have different radius of curvature r1, and this spherical surface will be having different radius of curvature r2. Are you getting my point or not? This is your biconvex. Number 2, equiconvex. Equiconvex. Now what is equiconvex? See, all equiconvex lenses are biconvex, but all biconvex are not equiconvex. Do you know why? Just because in case of equiconvex, the radius of curvature need to be same. Understood or not? Here also you are getting two convex. Here also you are getting two convex. Any lens which has got two convex are known as biconvex. So equiconvex has got two convex. That is the reason why every equiconvex are biconvex, but every biconvex are not equiconvex. Because for equiconvex, the radius need to be same. Number 3rd, you need to understand about plano-convex. Plano-convex. Now just say what is plano-convex. Plano means one side should be plane, the other side should be having a convex structure. So plano-convex means I just assume one side to be plane and the other side is having convex structure. Those side which has got plane, understood or not, need to have the focal length infinite. If the focal length is infinite, radius of curvature should also be infinite. Are you getting my point or not? The last one is your, got it? Concavo convex. Understood or not? Now you just say what is concavo convex. You please note it down. Concavo convex. Got it? Done? Concavo convex will be like this, in the shape of a crescent. Concavo convex. Over? Done? Concavo convex. Go for next. Types of concave lens. Types of concave lens. So will you be able to do it by yourself? Here also you will be getting the same term. Biconcave, equiconcave, plano-concave and convexo-concave. Are you getting it? So here you can write number 1, biconcave. Biconcave. What is biconcave? Here you will be getting different radius of curvature R1 and R2. This is biconcave. Same to same. The next one is your equiconcave. Equiconcave, where you will be able to see the radius of curvature will be same. This is R and R. Are you getting it? Third one will be your plano-concave. Plano-concave. One side should be plane and the other side should be having concave structure. This is plano-concave. Correct? And the last one, number 4, is your convexo-concave. Convexo-concave. Here you'll be able to see a structure like this. Please. Yeah, infinite. Yeah. One side will be having radius of curvature, the other, since it is plane, so the focal length need to be infinite. Over? Okay. So by using all those concepts, let us try to find out the focal length of different types of lenses. You please go for next topic and write focal length of different types of lenses. Focal length of different types of lenses. Different types of lenses. I'll just give you in the form of a chart, okay? Just make a chart like this. Here you can mention lenses. Here you can mention the focal length. Got it? We'll be calculating one more term where mu is 1.5. What will happen if the refractive index has got a value 1.5? In this case, what will happen to the focal length? Let's try to understand that. Got it? So first, in case of lens, let me calculate here for equiconvex. Equiconvex. Got it? What will happen if the lens is equiconvex? What is equiconvex, by the way? Both the radius of curvature need to be same, and we know very well that one of the radius of curvature should need to be plus, positive, right? The other radius of curvature R2 need to be negative. I already explained to you yesterday, right? So if I use the lens maker formula in this case, then I'll be getting 1 by f 1 mu 2. Got it? Let me assume that the light is entering from air towards the lens. For air, the refractive index is always 1. 1 mu 2 can be written as mu 2 by mu 1, where mu 1 is the refractive index of the air. So it must be equal to 1. So can I write over here mu minus 1 directly? Got it? 1 by R1. Since R1 is positive, so in place of R1 I am writing positive R. Wait, okay, I need to mention here R1 equal to R2 equal to R, for example. So since it is convex, so both the radius of curvature need to be same, right? So in place of R1 I have written R, since R1 is positive. According to the formula, it is minus of 1 by R2. R2 is minus or not? So can I write over here minus and minus, it will become plus, right? So ultimately I'll be getting 1 by f is mu minus 1. I'll be getting 2 by R. This is the expression of focal length which I'll be getting. Now what will be the focal length if the value of mu is 1.5? I'll be getting here 1 by fs. In place of mu, if I put 1.5, 1.5 minus 1 gives you 0.5. 0.5 into 2 gives you 1. So I'll be getting 1 by r or not. So ultimately you'll be getting f is equal to r. So for equiconvex, if the refractive index is 1.5, basically glass has got the refractive index 1.5. And if the lens is made up of glass, then you'll be able to observe that the focal length of that equiconvex lens need to be equal to radius of curvature. Is that clear? Please note it down. I hope you understand, right? Yes or no? Done? Okay, done? Let's try to calculate next number 2 for plano-convex. Plano-convex. What is plano-convex? One side is plane. And I told you those side which has got plane surface need to have the focal length infinite or not? Okay, for plano-convex, R1, correct? R1 need to be infinite. If focal length is infinite, then 100% radius of curvature also need to be infinite, right? R2 will be minus of R. Are you getting it? This is plano-convex, right? For this surface, the radius of curvature as well as the focal length will be infinite. But for this surface, I will be getting the radius of curvature or not? And let me assume the radius of curvature for this side is R. Got it? And we need to calculate the radius of curvature towards the left hand side. It is the reason why it should be negative. So R2 will be minus of R. What should be the value of focal length in this case? 1 by F. Here also let me assume that the light is entering from air towards the lens. So I'll be getting mu minus 1. 1 by R1. It is 1 by infinity. Minus of 1 by minus of R. It will give you plus 1 by R or not? 1 by infinity gives you 0. So I'll be getting 1 by F as mu minus 1 into 1 by R. This is the focal length expression which I got from the lens maker formula. Now what will happen if the refractive index is 1.5? 1.5 minus 1 gives you 0.5 and 0.5 is basically 1 by 2. So I'll be getting 1 by twice of R or not? So I'll be getting here 1 by F is 1 by twice of R. It means your focal length become twice of the radius of curvature. So for plano-convex, focal length is always equal to 2 times of the radius of curvature. I hope you understand. Please go for it. Done? Can you calculate by yourself equiconcave and plano-concave? I have calculated for equiconvex and plano-convex. Please calculate by yourself equiconcave and plano-concave. Please do it as soon as possible. Do it fast. R1 is negative, R2 is positive, and R1 equal to R2 equal to R. Now you just put this condition in the lens maker formula and do it. Do it as soon as possible. We have got lots of interpretation. Please do it fast. R1 should be negative of R or not? R2 should be positive of R plus of R, right? So your 1 by F need to be mu minus 1, 1 by minus of R minus 1 by R, right? So 1 by F will be your mu minus 1. You will be getting minus 2 by R. 2 by R, yes or no? Got it? For mu is equal to 1.5. What will be getting over here? 1.5 minus 1 will be getting 0.5. 2 into 0.5 gives you 1. So F will be your minus of R. Only the sign changes. For convex it was plus, F is equal to plus of R. For equiconcave you got F is equal to minus of R. Same thing you will be able to see in case of plano concave also. In case of convex you got focal length of plano concave is 2 times of the radius of curvature or not? It was positive, right? You will be getting minus of 2R in this case. Do it fast. This side will be infinite. Now since it is curved like this or not, it means you need to measure in this direction. The radius will be in this direction, right? And it will be along the direction of light, so it should be plus. R1 is infinite for plano concave, and R2 will be plus of R. R1 infinite होगा, infinite. प्लानो है ना, एक साइड तो प्लेन होगा, राइट? कैसे माइनस होगा? कंकेव है ना वो वाला. तो अगर ये स्फेरिकल सरफेस ऐसा होगा तो उसका रेडियस ऑफ कर्वेचर तो राइट हैंड साइड पे होगा ना. तो राइट हैंड साइड का मतलब क्या है? मैंने क्या बोला था आप लोग को? कोई भी चीज लेंस का राइट साइड पे हमेशा पॉजिटिव होती है. How you got this plus 1 by R?
Infinity, no?
R2 is positive or not? According to the formula, it is minus or not? So 1 by infinity minus 1 by R, it should be minus.
Like the same, F is equal to minus 2R.
Two times of R. Got it?
Yes, sir.
Done, everyone? You got F equal to minus 2R or not? Okay. So we have calculated focal length for different lenses. I hope you understand, right? Let's go for the next topic. There is the lens formula. Very simple. You are studying lens formula right from class 10. Yes or no? Please tell me, what is the lens formula? Yes, miss? What is lens formula? One by V minus 1 by U. Very good. So lens formula is basically a relationship between the focal length of a lens, image distance and object distance. Are you getting it? So you please write, you only need to understand the formula. Derivation is not important. 1 by F, 1 by V minus 1 by U. This is the lens formula. Please note it down. We will be going for question solving also, okay? Let me complete the theory part at first. Got it?
Yes.
Go for next. Magnification. Magnification. Just write. It is a ratio of size of image. It is a ratio of size of image to the size of object. Got it? In simple term. Understood or not? Only you need to understand the concept. At the end of the day, how much questions you are able to solve, that matters. No one is going to ask you what is the definition of magnification. So in simple term, it is just the ratio between the size of image and size of object. So what is magnification, by the way? I can write h prime by h. What is h prime? Size of image. I already gave you in case of mirror also. H prime is size of image. And what is H? Size of object. Got it or not? This is in terms of the size of image and object. Or we can also magnification in terms of image distance and object distance. Magnification is given by minus V by U. Got it? In case of mirror also we got M is equal to minus V by U. But you will be having little bit difference in the concept. In case of mirror, for real image, magnification expression was minus V by U. And for virtual image, it was V by U. But in case of lens, it will alter. In case of lens, for real image, it will be V by U. And for virtual, it will be minus V by U. Now, why it alter? I'll just prove it here. Got it? You please note it down till this much. M equal to minus V by U. Got it?
Yes, sir.
So let's try to understand at first for real image. For real image. For real image. See here, in case of lens, what should be the object distance? What should be the object distance? I told you already, object distance is always negative. Very good. And what should be the image distance for real image? In case of lens, it should be plus or minus? It should be plus. Very good. Why? I told you already yesterday. If the image is formed towards the right hand side of the lens, it is always real image. Got it or not? And if the image is formed towards the right side of the lens, and when we try to calculate the image distance, it becomes positive or not? According to the sign convention, right? So V is positive. V is positive for real image in case of lens. So what should be the magnification? M equal to minus of V by U. V is positive and U is negative. So minus of U, right? So I got a magnification as minus minus plus V by U for real image in case of lens. Please calculate for the virtual image by yourself. Done? You got M equal to minus V by U or not? Okay. So this is the magnification. Alright? So now let us try to understand the next topic. See huh? Just couple of minutes back we have completed the lens maker formula. Now we shall try to understand what happens if I immerse a lens inside a liquid. Every lens has got its own refractive index. If I consider a lens, the lens need to have its own refractive index or not? And if I immerse the lens inside a liquid, the liquid is also having its own refractive index, right? Got it? So what will be the change in the focal length in this case? And what happens if the refractive index of liquid is greater than the refractive index of lens? What happens if the refractive index of liquid and lens are same? If it is less, if it is greater, every interpretation need to be done right now. Are you getting it? So please go for the next topic and write. Lens immersed inside a liquid. Lens immersed inside a liquid. Got it? You just write a statement. If a lens of refractive index mu g, if a lens of refractive index mu g is immersed inside a liquid, of refractive index mu L, mu L. Got it? Then the focal length in this case will be, see here, for example, I just took a container. This is a container, right? In this container, I just poured some liquid, and the liquid has got refractive index mu L. Understood or not? Let me consider a convex lens, and I just immerse the convex lens inside the liquid. This is the convex lens. Are you getting it? Now the convex lens has got its own refractive index or not? Let me assume the refractive index of this convex lens to be mu G. Now the lens is inside the liquid now. Then 100% for sure the focal length of this combination will change or not? Got it? And that change in focal length can be understood only from the lens maker formula. Are you getting it? So I'm going to use here the lens maker formula. So what will be the focal length in this case? I'm just writing here FL. FL is the focal length. Got it? For the system when the lens is inside the liquid. Now in this case, the light will be entering towards the lens from liquid to glass or not? For example, the lens is made up of glass, mu G. The light will be entering from liquid to lens, right? I told you already, if the light goes from medium 1 to medium 2, we can represent it by 1 mu 2. If in this case the light enter from liquid to glass, then can I write over here L mu G? Yes or no? So in this case, I can write L mu G minus of 1. Got it? 1 by R1 minus 1 by R2. R1 and R2 is the radius of curvature of both the spherical side. Are you getting it? You please note it down and just put it as equation number 1. Understood or not? I hope you understand, right? This is in case of liquid, okay, inside the liquid. If I place the lens inside the liquid. Okay, now you tell me, if the lens is in air, then the light will be entering from air to glass or not? If I just take out this lens and if I place the lens in air, then the light will be entering from air to glass or not? So I can write in air. Let me assume the focal length to be FA in this case. Got it? This is the focal length of the lens in air. This is the focal length of the lens inside the liquid. I hope you understand. So here can I write A mu G minus of 1? Got it? 1 by R1 minus 1 by R2. Can I write like this? This is equation number 2, right? Now let me go for 2 divided by 1. Keep your eye on board now. If I go for 2 divided by 1, I can write here 1 by FA, 1 by FL will give you A mu G minus of 1 by L mu G minus of 1. Now you might be thinking, where does this term goes? If I just take the ratio, these two terms will get cancelled out or not? Got it? Now you just see, in this case, FL will be going up, FA will be coming down. So I can write here FL by FA equal to A mu G. I already told you 1 mu 2 can be written as mu 2 by mu 1. I hope you remember. So A mu G can be written as mu G by mu air. What is mu air? Refractive index of air. And what is the refractive index of air? Very good. It's always equal to 1. So if I write here mu G by mu A is 1. So can I write here simply mu G minus 1 or not? Because mu A is already 1, right? Divided by, in this case, if I break it down, can I write mu G by mu L? Mu G by mu L minus 1. So can I write mu G minus of mu L by mu L, right? High enough? So I can write over here FL by FA. This mu L will be going up, so I'll be getting a relationship mu G minus 1 by mu G minus mu L. By using this relation, I'll be going for interpretation now. Please note it down at first. Hit first. Over. Over. Done. Just go for star mark. Let's go for interpretation one by one. Okay, see, first point. If mu g greater than mu L, what does it mean? What is mu g? Refractive index of lens. And what is mu L? Refractive index of liquid. We have immersed the lens in such a way that refractive index of lens is greater than refractive index of liquid. Higher, na? Now you just go through the mathematical expression. In this expression, if mu g greater than mu L, then this term will be positive or not? The numerator will be positive anyhow, because mu g is basically 1.5 for glass. It is always greater than 1. Got it or not? This numerator is positive anyhow. Everything will be decided by this denominator. So we have considered a condition where refractive index of lens is greater than refractive index of liquid. Then this term will also be positive or not? It means the entire right hand side term will be positive, right? Now if I send this Fa towards the right, then Fl will be positive, Fa is also positive. It means both Fl and Fa will be having same sign or not? Are you getting what I'm saying? Both will be having same sign. It means nature of lens will not change in this case. Are you getting my point or not? Nature of lens will not change. This, if it is convex lens, it will converge the light. If it is concave lens, it will diverge the light. Are you getting what I'm saying? You please note it down. If mu g greater than mu L, comma, then both Fl and Fa, will be having same sign. Then both Fl and Fa will be having same sign, and mathematically what will be getting here? See here, this term is positive. We will be getting some term here or not? If I send Fa over there, then Fa into this term gives you Fl. Then 100% Fl need to be greater than Fa or not? Mathematically, right? Just write and Fl greater than Fa. Fl greater than Fa. Got it? Same line. In this case, the nature of the lens remain unchanged. The nature of the lens remain unchanged, but focal length increases. We got Fl greater than Fa or not? Higher, na? If I immerse the lens inside a liquid, we are getting Fl, focal length greater than Fa in case of air or not? So focal length will increase. And just tell me one thing, if focal length increase, then power should decrease. Very good. Got it or not? Just write, but focal length increases and power decreases. But focal length increases and power decreases. I hope you understand. Got it? Go for next interpretation. What will happen if mu g is exactly equal to mu L? Mu g equal to mu L. What does it mean? It means we have immersed a lens Got it? In a liquid which has got same refractive index with the lens. Now just look at here, look at expression. If mu g equal to mu l, then this term will give you 0 or not? Something by 0 gives you infinite or not? Infinite into Fa will give you again infinite or not? It means Fl becomes infinite. Just couple of minutes back, we have used focal length infinity, got it, at some certain condition. What was that? For every surface which is plane, we have used the focal length to be infinite or not? What does it indicate? It indicates that whenever I immerse a lens inside a liquid having same refractive index, both are having same refractive index, in this case the lens will not converge, will not diverge, rather it will be acting as a plain glass. Got it or not? And one more point, if you immerse a lens inside a liquid having same refractive index, the lens become invisible in this case. If I take out the lens, I can see the lens, but as soon as I enter inside a liquid, lens become invisible, दिखाई नहीं देगा आपको. Are you getting what I'm saying? Got it or not? Just write if mu g equal to mu l. Got it? If mu g equal to mu l, then focal length becomes infinite. Fl become infinite. That is the lens will behave like a plain glass. That is, the lens will behave like a plain glass and becomes invisible inside a liquid. And become invisible inside a liquid. Got it? Go for the third interpretation. In the third case, if mu g less than mu l, what will happen in this case? We have immersed a lens inside a liquid having refractive index greater than the lens. So what will happen in this case? Just look at a mathematical expression. If mu g less than mu l, then this term will be negative or not? Got it? If I send Fa towards the right, understood or not, then I'll be getting Fl is negative. Are you getting what I'm saying? Fl is negative, but please keep in your mind, in case of air, if I use convex lens, for example, we know very well focal length of convex lens is always positive in air. Are you getting my point? If I am considering convex lens right now, then in case of air, in air, this must be having positive or not? It means Fa should be positive or not? Are you getting what I'm saying? The focal length of convex lens is always positive. So if I consider convex lens in air, the focal length in air, let me assume it to be Fa. Fa means the focal length in air. So Fa need to be positive anyhow. But as soon as I immerse it inside a liquid, and the liquid is having more refractive index than the lens, then we are getting, according to mathematical expression, negative or not? Fl अपने आप negative हो जाता है ना यहाँ पे. If I consider mu g less than mu l, right? What does it indicate? Focal length becoming negative. इसका मतलब क्या है? Air पे वो positive था. As soon as it enter inside a liquid, it become negative. What does it mean? It is changing its nature or not? Got it? If in air, if it is positive, it was convex. But as soon as I immerse it inside a liquid, it become negative. मतलब वो concave का काम कर रहा है, right? है ना? If I consider the other lens then concave, for concave in air, it is negative. But as soon as if I immerse concave inside a liquid, वो अपने आप positive हो जाएगा. Sign will reverse. So if the lens in air negative, and if it is immersed inside a liquid and if it become positive, it means it is changing its nature or not? Are you getting what I'm saying? So if we immerse a lens inside a liquid having refractive index more than the lens, automatically the nature of lens gets altered. It changes. Got it? And how we are getting it? We are getting it from the mathematical expression. Please, if mu g less than mu l, then FL and FA, right. If mu g less than mu l, then FL and FA will have opposite sign. FL and FA will have opposite sign. That is the nature of lens changes. Nature of lens changes. Got it? Full stop. Same line you can write. Concave lens. Generally, concave lens are diverging or not, but it will begin to converge. Just write concave lens will begin to converge and convex lens will begin to diverge. उल्टा हो जाएगा. Got it? So these are some of the interpretation. Are you getting it? Is there anything you want to ask? Please do let me know if you have got anything to ask. I hope you understand, right? Whenever you go for the numericals, na, understood or not? Please try to use all those concepts. At first, you should understand what the question is asking, right? Okay. So let's proceed to the next topic. Let me complete the theory part at first. Just write cutting of lenses. Cutting of lenses. Cutting of lenses. See, if you consider a lens, for example, I am considering here a convex lens. Understood or not? This is the optical center of the lens. Got it? And let me assume that this convex lens has got the focal length f and power p, for example. Understood or not? Now what will happen if I cut down the lens? See, I can cut the lens symmetrically, got it, in two ways in this case. I can cut the lens along the principal axis like this. If I cut the lens, I will be getting 2 equal half. Or I can cut the lens vertically along the optical center in this way, and I will be getting 2 equal half. We will try to check here, if we cut the lens vertically or horizontally, will there be any change in focal length, power and intensity or not? Are you getting it? So whatever concept which I am going to explain you right now in this case for convex lens, you can use the same concept for concave. So at first I will be doing for the convex, got it? And you need to do for concave. Understood or not? So as I have already mentioned just couple of minutes back that we can cut the lens in 2 equal half, vertically or horizontally. Understood or not? So what will happen if we cut down? What will happen if we cut down the lens vertically? Then what we'll be getting? Let's see. So if I cut down the lens vertically, then I'll be getting 2 equal half like this or not? One half will be in this way and other half will be in this way, right? Hi Anna, we'll be getting 2 equal half. Now please tell me one thing. This half has got a name. What is the name? Plano convex. Got it? And what we have learned, just open the chart. For plano convex, focal length become 2 times of the radius or not? F become twice of r. If f become twice of r, understood or not? Then 100% focal length will also be twice. If the original lens has got focal length f, got it? Then in this case, single lens are, this is plano convex and this is plano convex, right? In this case, single lens will now be having focal length, sorry, you can write directly 2 times of the focal length. And power, since we know very well, power is power is reciprocal of the focal length, right? If focal length increases by 2 times, then the power will decreases by 2 times. Understood or not? For this lens also, the focal length will be twice of f and the power will be p by 2. I hope you understand. Got it? So if I cut down a lens especially convex lens, vertically you'll be able to see the half part will be having, the focal length of the half part will increase by 2 times and the power will be having p by 2. Understood or not? This is one of the case just right afterwards, and this is another case. What will happen if I cut down the lens in 2 equal half horizontally? Then I'll be getting a structure like this or not? This is one of the part, and I'll be getting one part like this. Yes or no? In this case, you will be able to observe no any change in power and focal length. This half part will be having PF. This half part will also be having PNF. Same. Understood or not? But you will be able to observe here variation in the intensity. Here you can mention intensity remains same. Here power and focal length will change, but intensity remain same in this case. But in this case, power and focal length remains same, but intensity decreases. Got it? Or you can write intensity changes. Done? Please do it by yourself for concave lens. This is for convex or not? Hmm. Hmm. Same. Here what do you have learned? Intensity remains same. Also intensity remains same. Over? Over not? सेम कन्वेक्स का जैसा होगा, कोई दिक्कत नहीं है. What happened? Same to same. Only just put minus 2f minus p by 2 minus p by 2. Intensity will remain same. Just write intensity. Here intensity remains same. Here intensity decreases. Got it? Done or not? Very good. Understood, right? How much? Done? Easy or not? Right? Very easy. This chapter is very easy. Done or not? Here? Okay. Okay, then let's go for next topic. Right, combination of thin lenses in contact. Combination of thin lenses in contact. Combination of thin lenses in contact. So try to understand. For example, we have got two lenses. This is lens number 1. Oh wait, I'm so sorry. Before starting this, we should understand about the power. Just write power of a lens. Cut it down, cut it down. Power of a lens. Power of a lens. Got it? Just write the ability of a lens. The ability of a lens to converge or diverge a light ray. The ability of a lens to converge or diverge a light ray is known as power. It's known as power. Got it? Or the reciprocal of focal length of a lens, or the reciprocal of focal length of a lens, focal length of a lens is known as power. Reciprocal of focal length of a lens is known as power. Got it or not? Now you just see, what we have written in the statement, that the ability of a lens to converge or diverge light ray. If a lens can converge more, then the power is more. If a lens can diverge more, then the power is more. For example, now see, we are talking about converging and diverging. Got it? Only convex lens can converge and only concave lens can diverge, right? So let me just take the example of converging power. So for that, I am considering two convex lenses. This is lens L1 and this is lens L2. Just keep your eye on board and try to understand. This is lens L1 and this is lens L2. When light passes through lens L1, we found that the ray of light goes like this. After striking the lens, understood or not, it converges in this way, right? In this case, in this lens, we found that when a ray of light passes through L2, it converges in this way. Now you just look at the two figure and tell me which lens can converge more, L1 or L2? L2. Got it? L1 is also converging, but it is converging less. It is converging more. Yes or no? Are you getting my point or not? And what we have written in the statement, that the ability of a lens to converge or diverge light ray is known as power. It means those lenses which can converge more need to have more power or not. In between these two lenses, L2 can converge more. It means L2 need to have more power than L1, right? Yes or no? Now you just look at the figure again. Since L1 has got less ability and L2 has got more ability. L1 has got less ability. There is a reason why the focal length of L1 is more than the focal length of L2 or not. Are you getting me? It clearly indicates that those lenses which has got more power need to have less focal length, and those lenses which has got less power need to have more focal length. I hope you understand, right? So from here also we can easily derive the idea that focal length and power need to be reciprocal to each other. More power, less focal length. Got it? More focal length, less power, right? This is in case of convex. You can easily determine in case of concave also. Let me assume it to be concave lens L1. Got it? And let me assume it to be another concave lens L2. I hope you understand. In case of L1, Got it? Let me assume that a ray of light goes like this. Got it? And it is diverging in this way. If it diverges in this way and if I just stretch the line, then the focus will be here or not? Got it? And let me assume in this lens what is happening. If a ray of light passes like this, got it? It diverges in this way. It means if I stretch the ray, I'll be getting focus here or not? Who has got more diverging power? L1 or L2? L2? L2 has got more diverging power. That is the reason why the focal length is less. But in this case, the focal length is more or not? Are you getting it? So in case of concave lens also, if the lens has got more diverging power, it need to have more, if it has got ability to diverge more, it has got more power. Understood or not? For both the cases, power is always 1 by F. And now this power can be measured in terms of a unit known as, please tell me, its unit is diopter, and please keep in your mind, this is SI unit. Got it? So you can write its SI unit is diopter denoted by D. SI unit, okay? So you should understand, whenever you go for a numerical, you should make sure that if the focal length in the question is given in terms of centimeter, samjha na? To calculate power, you should convert it into meter at first, because power are always measured in diopter. Are you getting it? Please note it down. Done? Do it fast. Done or not? Okay, go for the next topic. I hope you understand, right? Oh, wait. See here. Let us try to understand what should be the power for concave and convex lens. Below you just write for convex. Okay, just tell me, for convex, focal length is plus or minus? For convex lens, focal length is always positive or negative? Positive, very good. Focal length is always positive, right? Therefore, power need to be, since F is positive, so power also need to be positive. Got it or not? So, for any convex lens, the power is always positive. Keep in your mind. In the same way, for concave, focal length is negative, right? So power should also be negative. Got it? Now see, you are using lens or not? Huh? Maximum people in this world are having eye defect as myopia. And myopic eye can be corrected by using concave lens. And the power of concave lens is negative. most of you, I mean 100% of you, all of you are having myopic eye. For example, not for example, just tell me, what is the power of a lens? Minus or not? What is the power of a lens? Minus. What is the power of a lens? Even I have got minus. What is the power of a lens? Plus. Minus. Anyone who is having plus? You. Anyone? Yes, sir? So everyone is having minus or not? Minus means myopic eye. And myopic eye can be corrected by using concave. Are you getting it? आपका भी माइनस है? मेरे को मालूम है, बिना बताए मालूम. Understood or not? Okay, go for the next topic. Combination of thin lenses in contact. Combination of thin lenses in contact. So now see what will happen if I place, got it, 2 or more lenses in contact with each other, and if I ask you to find the total focal length of the system, so how can we find it out? For that we need a mathematical expression or not? I'm not going for derivation as I have already mentioned, but I'll explain you. Got it? I hope you understand what I'm saying. See here, for example, we have got one lens here and we have placed one more lens just in contact with the first lens. Let me assume that this is lens L1, this is lens L2, and let me also assume that both the lenses are having different focal length. This lens is having focal length f1, this lens is having focal length f2, for example. Now let me assume that we have got object O, got it, on the principal axis. From object a ray will be going like this. Now when the ray will be, when the ray from the object will be passing towards the lens L1, L1 will try to form image of this object O, yes or no? Image form hoga na? Whatever image which is formed by L1, that image will now be acting as a virtual object for the lens L2. Are you getting it? This is lens L1, this is object. Lens L1 will be forming image in this side. That image will be acting as an object for the lens L2 now. Again lens L2 will be forming the final image. In this way, what will happen if I place 3 lenses? For the first lens, whatever image we get, that image will be acting as a virtual object for the second lens. Again, I will be getting image from the second lens, that will be acting as a virtual object for the third lens. And final image will be getting after the third lens. Are you getting it? So I can use the lens formula for both the lens, but I'm not going for derivation. Understood or not? So if I assume f to be the focal length of this entire system, got it, then due to the combination I can easily find out the focal length as, here for the combination, number 1 I'm calculating focal length. Understood or not? Here for the combination, first I'm calculating focal length. So small f is the focal length of the entire combination, okay? So 1 by f will give you 1 by f1 plus 1 by f2. This is the formula to find out the focal length of the entire combination. Wait. Got it? Now number 2, if the question asks you to find the power of the entire combination, then in terms of power, we know very well that power is the reciprocal of focal length. Here f is the focal length of the entire system or not? Then 1 by f will give you the power of the system, right? P is equal to 1 by f1. In place of 1 by f1, can I write p1? 1 by f2, can I write p2? If I combine your n number of lenses, then p1 plus p2 plus dot dot pn. Got it? This is in terms of power. Third, what will happen if the question asks you to find magnification for the combination? Got it? If I assume or if I consider m to be the magnification here for the entire combination, then it will give you m1 into m2 for 2 lenses. What will happen if I combine here n number of lenses? You will be getting m1 into m2 into dot 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 mn. Please note it down.